This video is going to be about pages 6 and 7 in your trig ratios packet. I'm only going to do the even numbers though, okay? We are also going to cross out number 15 and number 16. So looking at number 12, we have our theta is x, and across from theta is opposite. Across from my right angle, that's the hypotenuse. So there's not a number here, so we're not really going to label it, but I just want to show you that this is the hypotenuse. And that means that 78 is my adjacent. So looking at SOHCAHTOA, should I use sine, cosine, or tangent when I'm trying to relate the opposite side and the adjacent side? So I'm looking for which one of these has the O and the A. Well, that's the TOA. So I'm going to use tangent theta equals opposite over adjacent. So fill those in. The theta is what we're trying to find. That's the x. The opposite was 25 and the adjacent is 78. Now I'm trying to find the tangent of x. So I need to get the tangent away from the x too. So to do that, you do the inverse tangent of 25 over 78. And you need to go to Desmos, go to function, inverse tangent of 25 divided by 78, and you get 17.77. And this is degrees because I'm trying to find an angle. Okay. Now for number 14, we are given theta is our x. That's what we're trying to find. Opposite of x, we have 10. And opposite of our right angle is our hypotenuse. So looking at sine, cosine, and tangent, just going to look up here again, sine, cosine, tangent. Which one do I have that relates the opposite and the hypotenuse? Well, that's the sine. So sine of theta equals opposite over hypotenuse. You want to fill those in. Sine of x equals 10 over 19. And I need to get the sine away from the x. So I'm going to do inverse sine of 10 over 19. Put that in Desmos. And we get 39.16. Since we're finding an angle, you put a degree sign. So now I'm skipping over 15 and 16. And I'm going to look down at these application problems. So looking at number 18, we have that somebody is flying a kite. And so we have a person flying a kite. And here is the kite in the air, right? Now the string is 275 feet. And the kite is 150 feet above the ground. So down here's the ground, we have 150 feet. Assuming that the string is straight, what angle does the string make with the ground? So I'm trying to find the angle that the string makes with the ground. So there we go. I'm trying to find x. And I'm given the number or the side of the triangle that's opposite of x, and the side across from the right angle, so that's my hypotenuse. So I have sine, cosine, or tangent to choose from. And I'm going to choose what one relates opposite and hypotenuse. That's sine. So it's going to be the sine of x equals O over h. So the sine of x equals 150 over 275. I need to get the x by itself, so I need to get rid of this sine. So we do inverse sine. So go to function, inverse sine, and we said 150. So go back to main, go 150 divided by 275, and that is 33.05. degrees. That's the angle that the kite makes with the ground. So I'm going to do numbers 20 and 22 on this page. And we have a 95-foot tall building. Let me zoom in here. And we are looking from a 95-foot tall building to a hot air balloon in the sky. So here we have a hot air balloon in the sky. And the angle of elevation from the top of the building to the hot air balloon, that is 76 degrees. So angle of elevation is always looking up. Now the horizontal distance between the building and the hot air balloon is 354 feet. And if I'm trying to find the height of the hot air balloon, I have to find the height from to the top of the building and then add back in the height of the building, which is 95 feet. So for this, I'm going to have my angle, which is 76. I'm trying to find the opposite side, the height of the hot air balloon, and I have the adjacent side. So I'm going to use tangent of my angle because that relates the opposite side, which is what I'm trying to find, over the adjacent side, which is 354. Now, in order to get x by itself, we're going to want to multiply by 354. So x equals 354, tangent of 76. So put that in your Desmos calculator. That is 1,419. .81. So that is just this height from the top of the building to the hot air balloon. And then we have to add in this 95 feet, which is the height of the building. And that's going to give me my total height. I'm going to have to run into problem 21 here. But if I add those together, I get 1,514.87 feet. That is how high the hot air balloon is altogether. Now for number 22, I have a surfer is riding a 7-foot wave. So we have a surfer up on a wave here. The surfer's up on top of a wave. Now this wave is 7 feet high. And then over here we have the beach. And it said the angle of depression. Now depression is somebody who's sad, they're looking down, right? So the angle looking down from the surfer to the beach, that's this angle here, is 10 degrees. What is the distance from the surfer to the shoreline? So I'm trying to find the horizontal distance here. I'm trying to find this x. So I have my angle, which is 10. That's my theta. I have the side across from it, so I have the opposite side. And I have the side next to it, which is my adjacent side. So we should be using tangent for the TOA. So it's going to be the tangent of 10 equals x over 7. So to get the x by itself, we're going to multiply by 7. And we're going to put this part in our calculator. 7 times tangent 10. 1.23. So the distance from the surfer to the shoreline is 1.23 feet. And that is for page 7. So we have learned that, I'm just going to make a little note down here at the bottom. If you are looking up at something, that is called the angle of elevation. If you are looking down at something, that is called the angle of depression.